Hopefully another fun and educational video here today at Blue Glow Electronics. As you can see, we have a Luxman 38FD, which is quite a unique creature. And this is the Mark II version of that. It's got beautiful tone controls. I can't even begin to tell you how nice and solid these are. Huge, nice power switches. Extremely well made unit. The downsides to these, they use a tube in here. It's basically a 50 volt compactron tube, and they're kind of pricey. A set of tubes will run you upwards of $300 or $400 if you're lucky. Outside of that, this is a solid unit. The guy brought this in, but apparently it was working fine. He took it over to someone else's house. They hooked everything up. They were listening to it. Things were fine. Then he turned around and brought it back home. And when he got it back home, one channel was extremely low. You can barely hear it. So I think they tested, made sure all the tubes were, nothing had jostled loose from a tube standpoint, and still having the issue. So I brought it to me to see what I could figure out. We're going to get it out of its case and get it on the bench. So these things have a screw right back here that I've already taken out. It's a screw with a nut, and I've kind of put it up for safekeeping. And then this metal piece slides out. Then you end up with this metal grate coming out. And at that point, you can actually see down in here and see the tubes. But we're going to get this thing flipped upside down so we can get the wooden cabinet off of it. Okay, and the way you go about that is you take these 6 screws out right here, as well as the 6 up here on the top. And this thing should come out fairly easily. Okay, I always put my screws and whatnot in a little magnetic tray so you don't have to worry about them getting lost. And at this point, as you can see here, it's just a matter of pushing the unit from the back out the front, and this whole thing will slide out nice and easily. Once I get it started, I usually flip these over on their natural stomach like this and take it out very gently out the front side like so, and you get the idea. And you can see we've got the cover off. These are the 50 CA10 output tubes that are so scarce. The rest of these are a combination of 6 DTHs, 62 67s, and 4 12AX7s over here on this side. So nothing extremely rare there. Nice power supply transformer. Nice little choke for the power supply. Then you got 2 nice push-pull transformers here made by Luxman. So good stuff. Okay, a lot of connections on the back here. Very versatile amp. Not crazy about the little speaker jacks right here. I think they could have done a better job on those, but all in all, not bad. If you'll notice one thing on a little odd here though, AC 100 volts, 50-60 hertz. So you end up having to use a step up, step down transformer and actually feed this thing with 100 volts here to be able to run it in the US. This thing was made in Japan, designed to be used in Japan. Okay, before we take this thing to the bench, I'm going to take these 4 screws out right here, take this top plate off, and I'm also going to get the bottom plate off of it. That way when I get it on the bench, I have full access to everything. It's pretty interesting cabling and really nice little switches down in here, but I thought the use of some cable actually wrapped around, or wire wrapped around and around as wire wrap was a pretty interesting little technique down here. And then you can get a good view underneath here, all the coupling and bypass caps feeding into these tubes, the push-pull transformers here, the bottom of the choke, the bottom of this power transformer. I just love this Japanese craftsmanship. It's amazing. And then kind of what feeds these output tubes. Little sockets here, if you notice, for biasing these output tubes. Super nice build. I tell you, for what these things cost, this should be up there price-wise. These things run anywhere from about $1,800 to $2,400 if you can find one. Shipping's usually the gotcha, because they're usually coming from overseas, and you'll pay a couple $100 shipping. But I mean, this is high quality stuff, I have to say. Okay, first thing I'm going to do is test all the tubes in it. These are the 6 DT8s. You can use any good tube tester. I'm using the Cartomatic computer controlled unit here that I love, but 6DT8, hit enter, and there is the tube. You come over here then, plug it into the socket, if I can see that far. Get it down in there, hit the T button for test, and lo and behold, it's warming up at this point. Keep an eye right down in here for any shorts. This light here is telling you that it's a two-sided tube, so at some point I should be able to kind of hit it here. And if you notice, this thing's testing really good. It's up there in the 85 range, almost 90, 87. I hit the other side, it's a little weaker. It's down around 75. So it's not a perfect tube, not exactly balanced. You got 87 on one side and about 76 on the other side. But I don't think that would cause it to be completely dead in one channel. I'm going to go through and test all the other tubes at this point. Okay, I thought I'd show you these weird little speaker jacks on these. When you screw them out just a little bit, you get a little bit of a notch, like you could wrap a wire around there, but as you screw that back in, it kind of starts to cut off the wire. The way these things are designed to be put in is basically you need to strip enough wire to have about an inch sticking up. And what you do is you stick this through the front side right here, and then it goes all the way through, and then you kind of take it on the back side and you bend it over to right there so that it's kind of sticking there. And then at that point you kind of screw this thing in and it locks that wire in really well. That's the way these things are designed to be used. Okay, we've got all the tubes back in it. All of these tested fairly well. The 12AX7s, two of them tested fairly weakly, two of them were okay. One of them was just so good, but the other one was okay. So my buddy had sent along a couple spares, but turns out he sent 4 spares. Only one of those was any good, so I put it in. So one of these is a little weaker than I would like, but I don't think it would affect the complete not working that the customer was talking about. It more than likely would just cause one channel to maybe be slightly lower than the other, or it would just wear out sooner than any of the others. Okay, as you can see, we've got all the speaker wires in here good. We've got a set of RCA cables that are then feeding up into a function generator. So we're going to drive this thing with a 1 kilohertz tone. See what we get out of it. Okay, we've got the unit brought up on a power supply brought up on a variac, and we're going to turn this thing on. And we've got nice little got lights, and let's see if we get some sound out of this thing here shortly. Let's give it a little bit of volume. Nothing yet. Let's see, we're on the main, we're on stereo, power. Let me check a couple things. And I figured it out. I had plugged into the remote speaker system instead of the main, and we're not getting a lot out. I hear a little bit out of the left channel, not much at all out of the right channel on this thing. I'm going to move them over to the main power, the main speaker in. Okay, we're driving this thing pretty hard, and as you can see right now, if you can get a good clear view of that, pretty darn fuzzy sine wave coming out of this thing. And if you'll notice over here, I'm driving it with 0.4 volts, which is about line level. We're running at 15% distortion right now. And if I switch to the left channel, you'll notice it even drops down even further. So we got a little more on the right channel than we do on the left channel. Just not looking good at this point. We're really not getting a lot of output either. I mean, if you look at this, we're in the millivolt range here on what we're getting on the output, 277 millivolts. And that's with the volume turned all the way up, 280 millivolts. So we're really not going through these output tubes at all, I don't believe. We're dying somewhere in the signal path. Okay, I flipped it upside down now, and just to show you kind of the setup I'm working with. Got the Fluke digital multimeter here. I've got the negative lead of it grounded to the chassis, and then I've got just a Fluke probe tip here. And I'm just going to go through and start checking some voltages. I'm going to see if I can find a service manual, but I want to make sure that we got good B+ voltages on the output tubes, on the input tubes, make sure that we got bias on those things, things of that nature. So we're going to dive in and start testing some of that. Okay, I thought I'd show you this. I'm driving it with the function generator, and I'm going to drive it right here into the oscilloscope. Let me lock this down, and I'm going to change this over to dummy load, and the same over here so we don't have to hear it. And what I've done, if you take a look here on the back of this thing, I have actually fed down into here the main in, and I have flipped this little switch right here that jumpers the pre-in to main, pre-out to main in. So basically what I've done is I've bypassed the entire front end of this thing, and I'm just getting to the 4 output tubes, driving directly from an external source. And let me zoom this back out and you'll get a feel for what I'm talking about here. So as I turn the volume up a little bit here, look at this. We're able to drive all the way up to right there. It starts clipping a little bit. We're at 23.85 volts out on the left channel, and right in the same range, 24 volts out on the right channel, which is way more than we were able to drive. Driving through the input on the preamp side of this thing, the most I could kind of get at all was around somewhere in the neighborhood of about less than a volt out on this thing. So something on the preamp front end of this thing is really just killing the whole thing. And the volume seems to work. That's not even all the way up on the volume, by the way. But then again, the volume is cut out. At this point I forgot I'm feeding on the main end, which bypasses all the circuitry on the front of this thing. But yeah, you can keep driving that thing right there. It starts to clip, but you're starting to get about, wow, on up there, 20, almost 30 volts out on this thing. And let me do the math on that. I did the math on that. So you want to do peak, which if that was 30 volts, it'd be half of that, 15. 15 times 15 divided by 8. You're getting out about 28 watts out of this thing, which is about right for these tubes. So yeah, it's putting out exactly what it should, just struggling a little bit on the whole front end. So at least I know where to focus. It'll be here on the front end. And I think we're going to go to bed for tonight and pick this thing back up in the morning. Okay, after a good amount of time diligently searching, we finally found a clean schematic. There are several online, very few of them can you actually read the details. And there's also a service manual out there, but it's written completely in Japanese, so it didn't help me out a lot. But what I thought I would do is walk you left to right through this amplifier and follow the signal flow here on the schematic, which should be a good foundation for us then getting over on the bench doing some troubleshooting. And this is a great little segment for anybody wanting to learn how to troubleshoot a receiver, whether it's solid state, tube, or what brand. What I'm about to explain to you would apply to any of them. So first we're going to come in right now, we're plugged into aux1, and we'll kind of follow the signal over. It comes through this first switch, which is kind of ganged with this. It's kind of the function switch. You switch between these inputs here. But ultimately it kind of leads you over here into this section here, which is basically the balance for the left and right channels. And then you get into VR2A here, and if you look at that, that's basically the volume, VR2A right here, volume, and we went through VR1A, which was right here. So once you leave the volume switch, then basically you feed up right here and into S4A, which is the low cut switch. Then you kind of feed over into, and you jump into your first V2 right here. A would be one side of V2. And if you'll notice down here, V2 is a 12AX7. You kind of feed out of it. You go through some more switches here, which are kind of the high cut. Then you ultimately feed here into V4A, which is another 12AX7 right here. And you kind of feed out of it. And then this is where it gets interesting. You come out of that, and you can go out the pre-out at that point if you chose to, based on the switch settings right here. And you could feed in via the main in. But if you have the switch turned kind of the default way, it takes your signal out of this, off the plate, around over here, and then it takes it into V5. If you notice here, V5 is the a 6267. Then it leaves the 6267, kind of goes into a phase inverter here that's made up of the 6DT8, and then it kind of leaves that and it jumps here finally into the last tubes, which would kind of be V9 and V10 here, which are the 50CA10 tubes, which are, you can see here, 50CA10, the final output tubes. So, bottom line on that is that, as you can see here, the last output, then you hit the output transformer, and then basically you go out to the main and remote speakers. So, left to right, this is basically your preamp stage, 212AX7s. This is your phase inverter and a little buffer here. And then finally you get to your output tubes right here. And what I mentioned was earlier, when I fed in right here on the main end, and I switched this little switch upwards so that it would take the signal, bringing it in here and cutting it off from the rest of the, the front end of the amp. As you flip that little switch up right there, all of a sudden you're getting your signal from the main end. When I fed the amplifier right there with a signal, the back half of this amplifier, basically everything from here over played perfectly. So no issues whatsoever on the last final stage of the amplifier. Okay, hopefully that made sense to you. So let's then pretend instead we fed into phono right here, right? Well, if you'll notice, it comes over here, kind of goes through this S1A, which is the switch, part of this whole switch setup right here. And it would feed it straight over into V1A. And if you'll notice down here, V1A is a 12AX7. And it would go into then V2A, which is also a 12AX7. By the way, all this is mirrored down here on the bottom on the right channel. So I'm just showing you one channel of the amplifier right now. But then you feed into the second side of the 12AX7 or second 12AX7. Then you kind of feed out of that, and if you'll notice, where does the signal go? It comes right here. It feeds back over and into this switch here to then get sent over back through the balance, back through the volume, and into the preamp section. So here's the reality. If we don't feed in the phono section, which we haven't thus far on this amplifier, then basically this whole section right here has been bypassed. So if we know this whole section is bypassed, and we know that this whole section down here with the finals is working, well, guess where our problem must lie? Somewhere between right here and right here has to be where the problem lies in this amplifier. So we're going to be able to focus on these two 12AX7 halves. But interestingly, we got the same thing going on down here on the other channel. So got to focus on both sides of that. But I hope you get the idea of how we've narrowed down. Instead of having to work on this whole schematic, we've kind of narrowed down exactly the area of problem by one, bypassing the phono, and then two, feeding in on the main end. I do this all the time on Marantz amplifiers or Marantz receivers. I'll skip the phono, I'll feed in, I'll get into this preamp section, I'll test and see if the main end works. If it does, if I've got good scent on the output, then I know it's something in this section. If you can also feed out the pre-out, and if you're feeding into another amplifier, you may get a good signal from here, but you're not getting anything out on the output. You would know to chase that. The one other thing I've done over on the bench is I kind of pulled up the power supply section here, and you can see a couple places here. It'll kind of tell you 60 volts, 350 volts, whatnot. I just did some basic voltage testing and found out that it seems to be everything in the power supply seems to be working okay on this thing. So now that we've got a good idea on where to chase, which would be kind of this section right here, let's jump back over on the bench and do some testing. Okay, one place I want to start, I did want to point out before we jump to the bench. I want to grab a little clip and feed from my signal generator, and I actually want to jump right here onto the grid of this first tube in the preamp right here and feed it right here. That'll tell me a lot because basically at that point I would be bypassing all this circuitry right here, the volume and the balance pot, as well as the switch up here. So I've even further would be removing components. So, you know, just kind of dissecting, taking little pieces at a time, trying to remove things that it might not be. For example, if I fed right here and had good signal throughout the rest of the amplifier, then it would likely be something in the switches or maybe this, you know, low cut section or something. So that's kind of the way we're going to work along, is just feeding at different points. And once I'm feeding here, then I can start measuring along the way as well with the oscilloscope. Okay, one last little thing before you dive in. You might want to have a good, you know, 9-pin bottom view, you know, pin out, so that you know which pins go to what. So as you're chasing this down over there and you're trying to chase the grid of one tube here, well, you'll know that it'll either be pin 2 here or pin 7 would be the grid. One of these would likely be for the left channel, one of these for the right channel, because this is actually two tubes inside of one. It is a dual triode. Okay, the good news is we got this amplifier turned up here on the bench with the camera mounted. This is the kind of connection I'm going to use. I'm going to actually feed that up into my signal generator, and then the other end of this, you can see here, just has a you know, a ground and a you know, positive connection, and that's how we're going to do. We're going to start feeding down in here, see if we can figure out where that point is I showed you on the schematic, and feed this thing and see what we get on the output at that point. One thing I thought I'd show you real quick, got the variac turned on and brought up, and I'm going to hit the power switch on this amplifier, and I want you to watch this AC current meter. Did you notice where it bounced all the way over here to 4.5 amps of current, then it came back down to less than an amp of current. That's why you have to use slow blow fuses in amplifiers, because the transient response from the initial turn on can be 3, 4, 5 times the ongoing load. Okay, what I'm doing at this point is I'm feeding out of the HP8903 audio analyzer. I've grounded this lead right here to just kind of the signal path ground on the schematic, and the red lead right here goes to where I showed you on the schematic I was going to feed this into right before the 12AX7, the grid on the 12AX7. So check this out. I'll show you this parallel video, and what this is showing is the actual 16.25 volts out on the output with a beautiful sine wave. And if you'll notice, I can swing over this way. We're actually getting 0.169-0.17% distortion. So this thing is looking really good at this point. So what that's telling me is if I can actually get a signal to right here, then you know, we're good to go. We can we make it through the rest of the amp. For some reason, we're not getting from the aux port in the back here up to this point successfully. And for fun and giggles, I've now moved this lead over to the other channel. And if you'll notice, I'm getting out a very similar 16.9 volts. And we've got 1.6% distortion here. So our issue does not lie in the output section of this thing. It does not lie in the preamp section, and we've not even used the phono section, so I know it doesn't lie there. The problem is something between this aux input and this stage right here. So check this out. We tested earlier right here, right before the grid of the first 12AX7 in the preamp stage, and my little check mark says all that was good. Up next, I'm going to connect right now to the wiper, basically, on the other side of this circuit here of the balance control, and of the volume control, and let's see what we get. So you can see the oscilloscope here. You can see I've got it connected in. Let me see if I can tilt it here onto the middle wiper here of the volume pot. When I turn that on, I start getting signal. I can drive that thing all the way up to 30 volts. Beautiful clean sine wave. So it's definitely not the volume pot. so next then, let's move one more to the left and jump over here on the wiper of the actual balance pot. Okay, we're now connected on the wiper of the balance pot there. Seems mighty quiet here as I turn the volume up. Look at this. As hard as I can drive it with the function generator, I can hear a little bitty tone in the background, but I have to crank this thing way down. And look, I'm starting to get out this 0.385 or so millivolts there of signal. So something in here in this balance pot area is killing us. All right, we have figured out the issue at this point. So remember, we tested here, we were good. We came back over here, tested here on the wiper, we were good. We came over here and we were starting to die out over here. And what I found out was this little switch right here, which is kind of the mode / monitor switch, got a couple blades to it, has some issues. I think someone's used some deoxide on these switches before and they've warped and not making good connection at this point in time. So I'm gonna have to talk to the customer about whether they want me to jumper inside this thing and basically bypass some of these switch areas, or whether we want to try to find a replacement switch here, probably coming out of Japan, which would be much easier to find if I could speak and or read write Japanese. But Google Translate may help me a little bit with that. So, you know, I basically came over here and tested from the aux1 port all the way to this contact on this switch right here that I'm pointing at with the little arrow right here, and all was fine. When I got over here into this, and I checked this 47k ohm resistor, it seemed fine. It's when I got into these three stages right here, not getting good connection and connectivity to actually pass the signal through. I tried cleaning it a little more, didn't help. I think we've got some wafers in there that have warped over time. So we will see. I'll talk to the customer and we'll kind of take it from there. But hopefully hopefully you've learned something here. We've narrowed it down. I don't know what kind of luck I'll have in finding this part. I may end up just soldering some jumpers to bypass some of this and get the amp going that way. We'll see how the customer wants to go. Thanks for watching, everybody. Hopefully you learned something. This was a really good troubleshooting step on how to kind of step by step break something down and figure out what was wrong with an amplifier. Thanks for watching, everyone. Okay, for the fun of it, I went in here and tacked a couple jumpers in here just to prove that this thing works at this point. And check this out. Nice sound wave left and right here. You can see up here on the oscilloscope. Let's get zoomed in a little bit. Starting to get a little clipping up there around 28 to 30 volts, which is about right for this thing. Hang on one more second. Let's grab our little aux cord thing out of here and throw it into our handy dandy iPad, or little iPod that I keep on the, I keep this thing here on the bench, just a little thought we'd throw it back on the dummy load. I'm going to drive it pretty hard here with the let's see, let's get this thing up here around, oh, we're pushing hard right there at 28 volts. Okay, output. Look at this, 0.19% distortion. We'll turn on the and that's the right channel, left channel, just a slight bit more distortion. If I bring it down just a hair, you see it drops quickly as soon as I get down in the 26, 27, 28 volts. We're right there at the clipping stage. And last but not least here, running the look at that clean 1 kilohertz, really no secondary odd or even harmonics whatsoever on the left channel, the right channel, nothing there as well. Super happy with how this thing turns out. I just got to figure out what we're going to do about this switch in this thing. Thanks for watching, everybody. Stay tuned, we got more coming.